All right, everyone. Thank you so much for being here today, and welcome to this session, which is basically an extension of ML. So what we're going to basically do in today's session is we'll talk a little bit more about all that we've learned so far. If there are any doubts that you have from the previous 3 sessions, we'll get that all clarified. And then the terms and things that we're going to talk about in this session, maybe certain things you might have heard of in the previous sessions, but we'll understand a bit more about all of these terms. And I'll ask you a few questions in such a way that you can also think and design an ML system for yourself. So let's get started with our usual recap. So the first question would be, what is machine learning? So machine learning is basically the program just learning from data. We, as a programmer, we're not giving the machine any rules for it to operate. So now that we are not giving the machine any rules for it to operate, could someone tell me what is that type of programming where we give the machine rules to operate on? Could you name it? There are a couple of names for it. So in machine learning, we don't give any rules. Yeah, Anshul, go ahead.
It's the traditional method.
Traditional method, exactly. Does anyone know any other name for it? All right, so what Anshul said was one answer, that is traditional programming. Another thing that it's called is rule-based programming. So rule-based programming is that programming where we as a programmer, we basically give the machine all the specific set of rules that it requires to operate. While in machine learning, we don't give it any rules. We just provide it data and it just learns on its own. We don't give it any rules, or we don't explicitly program it. It learns from the data on its own. So that's machine learning. So now that we have machine learning that can basically learn from the data on its own, what is this thing called neural networks and why do we need that? All right. So let me tell you how neural networks is different from machine learning. So machine learning, while it does learn from data and we're not explicitly programming it, there are a few instances where there is still some human intervention. Take, for example, this thing known as supervised machine learning. Again, if this term is quite new to you, don't worry at all. I'll be explaining it a bit more when we further move on in this session. But basically, supervised machine learning is this type of machine learning where the programmer provides the model with labeled data. That is, if now you're training a model to differentiate between a dog and a cat, then you given pictures of dogs and cats to the model, but you already know which is a dog and which is a cat. That means that you have already labeled the dog and the cat, and that is what you're feeding to the model. So unsupervised learning is the case where you're just randomly giving in images. Even you haven't really labeled which is a dog and which is a cat. You're just feeding in an influx of images to the model and it's trying to learn on its own. But with supervised learning, what you're doing is you're specifically labeling these things. So when it comes to things like that, there is a lot of human intervention. And usually when it comes to, let's say, image data, actually in this example where I'm saying a dog and a cat, a machine learning model might not perform really well because it gets a little difficult for it to identify all the features of a dog and a cat and differentiate them. It may perform well, but what would perform better is a neural network. So what is this neural network? Neural network is basically something that's modeled off of the neurons that are present in our brain. So in our brain, the functional unit in our brain is called a neuron. I'm sure all of you might have learned or heard of this term called neuron in biology that you may have taken in class 8, 9 or 10. So these neurons are connected in our brain and that's what forms a network and that's what allows us to do things. So similarly, what we're trying to simulate for a machine learning is a neural network. So in neural network, basically, it's able to identify more features when you're given images. And not only is it able to identify more features, it's also able to perform better and with lesser human intervention. So you don't need to label this data specifically, or you don't need to have a lot of human intervention. What happens in a neural network is that once you're given the data, it starts learning on its own. Definitely makes mistakes, but the neural network on its own gives feedback to itself. So from that feedback, it corrects itself and continues to learn and learn in this manner. So that's a neural network. Think of it as a larger, like if you have a lot more data. So maybe machine learning can be used for things like, let's say you have the data of students and the number of hours they study and the number of marks they get. So using this model, what you want to do is you have students and the number of hours they study. Based on the number of hours they study, you want to predict the number of marks they get. So for this, you can use some machine learning models to make a model out of it, because it's all features that's given in text or numeric format. But for images, what would work better is a neural network, because that can learn more features, can differentiate better, and it has its own feedback mechanism. So it does not require a lot more human intervention like the machine learning models do. So I hope that part is clear. So machine learning systems take input data and make useful predictions and decisions about previously unseen pieces of data. So this is exactly what Anchal also mentioned in her definition. They take input data and they make useful predictions, and they also take decisions about previously unseen pieces of data. So this if you remember from the very first session, I'd mentioned that there are 3 phases when a machine learning model is made. That is training, validation, and testing. So in the training and validation phase, you're teaching the model how to recognize patterns based on the data that's given. But in the testing phase, you're giving it previously unseen pieces of data. So that's what this is. Then machine learning is a specific field of AI where a system learns to find patterns and examples in order to make predictions. So you do find, so when a data is given to a machine learning model, what does this model do? It basically understands the underlying patterns of this data. It tries to find out the features that are present here, and using this, it makes predictions. So that's what machine learning does. So this, again, going back to what Anchal mentioned, this is what she said. She said, it's computers learning how to do a task without explicitly being programmed to do so. So in a rule-based programming, we already give the machine the rules it requires to follow. But in machine learning, we just provide it with data. From this data, it has to learn patterns, it has to learn features, and based on these patterns, it will predict output on previously unseen data. And basically the model is doing this all on its own. We're not explicitly programming it beforehand. So that's about machine learning. So machine learning system might label or classify your data. It may predict some numerical values. It may cluster similar pieces of data together. It may infer association and patterns in data, and it will create complex outputs. So these are different things that a machine learning system may do. So what can it do? It can label or classify data. So that refers to classification. That was an algorithm we learned in our second session, where you basically give the machine learning model a few, like let's go back to our dog and cat. So dog is one class and cat is another class. And what your machine learning model is trying to do is it's trying to differentiate between a dog and a cat. So that is classification. You have only 2 possible outputs, and the machine learning model will take a new image and try to classify it to either one of these outputs. Then you predict numerical values. Now that refers to regression. So what happens in regression is that you don't tell whether it's a dog or a cat. You don't say that. You give a numerical value here. So let's say you have to predict, like I was mentioning in my previous example. So you have the number of hours a student studies. You want to predict their marks based on the number of hours they study. So to do this, what you're doing, you're in the end predicting a number. You have a feature. From that feature, you're learning some patterns. And based on that pattern, given unseen data or previously unseen data, what the model is doing is it's predicting a numerical value. So that is regression. Then you're clustering pieces of data together. So that is a clustering algorithm, which falls under unsupervised learning. Again, I will go to these in a little bit. So you can infer association or patterns in data, and you can create complex outputs as well. So these are some of the capabilities of what a machine learning system may do. Now, machine learning, why or why not? So it's not always that when you have a problem, you should immediately use machine learning for that. There are also rule-based strategies that you can apply. So can any one of you give me one example where you can use rule-based type of approach rather than using machine learning? Any one instance off the top of your head where you think it could be the most basic example. Think of the problems you encounter day to day. Based on those problems, can you think of maybe one instance where you don't really think machine learning will make this better rather to make it more complex.
Watering the plants.
That's a very nice idea. Yes, watering the plants. That really does not require a lot of machine learning because, okay, now if you can possibly model that to be a machine learning problem. So if you think of, let's say, now if the problem is framed in this manner, every day at 12 o'clock, water the plants, then that would be a rule-based approach. You just have to write a model that says at 12 p.m. every day, water the plants. But if it says differentiate the amount of water you give to the plants based on how the soil is. So sometimes the soil is already very moist, and if you overwater a plant, that's not very good. But sometimes it's dry and you need to give it, like sometimes, the plant is probably not doing very well, so you need to give it more water than is required at that particular moment. So that could be taken as a machine learning model because there are different features for you to learn from. There's the soil, the degree of moisture in the soil, the wilting of leaves maybe. So the leaves that are actually wilting, you need to know that the soil is devoid of water. So you need to pour more water in that case. But if you feel like the soil is already moist and things like that, then you need to reduce the amount of water you poured there. So that's how that could possibly be a machine learning model. But yes, if you just say pour 1 can of water for each plant at 12 o'clock, then that possibly does not require machine learning. So Amok, that was a really good answer. Anyone else has any other ideas why maybe like some cases you think machine learning, that won't do the trick? All right, let me reverse the question. Do you have any cases where you think machine learning is actually properly required? Like, hey, this problem could possibly be better with machine learning. Anything that you can think of? Again, look at your everyday life. What are the, like Amol very nicely mentioned, an everyday life problem is watering plants. So he very nicely mentioned, oh yes, Tejas, you have an answer?
We can use it in a car, means automation car.
Yes, automation cars. So you mean to say self-driving cars?
Oh yes.
Yes. Okay. Yes, absolutely. That's a really wonderful answer, Tejas. So actually, companies like Google and Tesla are working on self-driving cars. So you can actually go check it out. Google has their own self-driving car unit, a subsidiary called Waymo, where they're actually working on these self-driving cars. And that does require a lot of machine learning because for the car to drive on its own, there will be many sensors that are attached to the car. And based on those sensors, it gets input such as how is the floor, like it has to get input from the GPS because it needs to know where it has to go, which direction it has to turn. And it also needs to know what's the speed of its travel, because what if there's a person coming in front of the car? Then it needs to know it has to stop. What if the roads are really bumpy? It cannot go at full speed. It needs to reduce its speed. So for things like this, machine learning is involved. So really great answer, Tejas. A self-driving car does require machine learning. So these are a few things you can ponder upon, and there's an abundance of articles, TED Talks, videos about machine learning. So you can always look and ponder upon more situations where you think traditional programming would perhaps be more efficient. Think of certain cases where you maybe think, hey, would a human perform this task in lesser time? And also think of certain cases where you think, hey, maybe this task a human shouldn't perform, but a machine should perform because that would make it better. Because ultimately, what are we all looking for? Efficiency. We're all looking for efficiency, right? Whatever task we do, we want to make it more efficient. So, like I mentioned, for a very simple problem, if you use machine learning, that is not efficient. You're just overcomplicating the problem. So for you to have efficiency involved, you need to think of these areas. Is machine learning necessary here? And this is something that you need to think of even while doing your course projects. You may think that, okay, if I do a project in machine learning with this problem statement, it will be great. But actually take a step back, take a minute and read the problem statement and think, is machine learning really involved here? Because if it's not, you shouldn't be pursuing it because you're just simply overcomplicating the problem. And when you do realize that machine learning is something that's required, think of what benefits does a machine learning model have in those instances. So like I mentioned in the previous example, as Amog suggested, if you have watering the plants as an example, and if the task was just simply to pour a can of water for each of the plants present at 12 o'clock every day, then you don't require machine learning. There are just 3 very well-defined rules. What more is a machine going to learn when you use machine learning in this problem? But if it is something like based on the wilting of the leaves and the soil texture, pour the required quantity of water to the plant, then in that case machine learning is involved because it has to learn something. It has to understand patterns. It has to look for features such as wilting of the leaves and the soil, and it has to look for patterns also there. If the soil is not that moist, then pour more water. So these are the patterns and things it will look for. So these are a few points that you must keep in mind when you're looking about machine learning. All right. Now I'll little bit more in detail explain what's supervised and unsupervised learning. All right. Now to explain supervised machine learning model, let me take a very, very basic example. Think that you have a cousin, a baby cousin, and your task for today is to teach your baby cousin the color red. So what are you going to do? You're going to basically bring in some things that you already know are red color. So maybe you have a red color pencil. Maybe you have a red color cardboard piece. Maybe you have an apple. Maybe you have some other things. Maybe your pinup board is colored red. Maybe your table is in the color of red. So all of these items you'll bring in front of your cousin and you'll be like, okay, so can you see this? This is the color red. That is how you're teaching a baby how to understand the color red. Then once you're done teaching red, your task for the next day is to teach blue. So then you again assimilate a lot of blue colored items and then you show it to your baby cousin and you're like, okay, so look at this. This is the color blue. So now on the third day, what you do is you bring a red color pencil and you're like, okay, what color is this? So the first day you already got a lot of artifacts that are red color and you made him understand what the red color looks like. Then on the second day you got blue artifacts and you made him understand what the blue color looks like. So there is a good chance that that your cousin will probably be like, oh, okay, this is red color because that's how it's learned. So this is what we're doing with supervised machine learning model. What we're doing is the model is trained on labeled data. That is, for example, if you take the same exact example, instead of teaching your baby cousin to differentiate between red and blue, imagine you want to teach a machine learning model to differentiate between red and blue. So what you do is you give it a lot of data. Now you already know that this data is red in color. Okay, so you give it a lot of data that's red in color. Then you also give it a lot of data that's blue in color. Now you already know that this data is red in color. You have labeled it as red and you've sent it to the model as red. You already know the other data is blue in color. It's labeled as blue and it's sent as blue. So based on this labeled data that you have sent the model, it will learn on its own and it will understand, okay, so this is how red looks like, this is how blue looks like. So when you test it and when you give it some unseen data, let's say you give it the color red, or like let's say you put an apple in front of it, then it will be like, oh, okay, so from what I've learned from the features of the red color data and blue color, this does not look blue, it rather looks red. So it will give you the answer that the unseen data you're giving is red in color. So just think of supervised learning like you're teaching your baby cousin how to learn something, like how you're teaching a baby how to differentiate or learn something. So that's about supervised learning. You're already giving in label data. Now, based on this, unsupervised learning is basically you're giving it unlabeled data. Oftentimes, we don't have time to label all the data that we're giving to the machine learning model. Sometimes we don't know the data that we're giving to the machine learning model. We just want to learn, we just want it to learn on its own. Now, for a real life example for you to understand this, let's say suppose you're the head of, a team, and now you need to understand some way you have like, let's say 5 people under you or 6 people under you. You have to understand some way in which these people are similar. Now you don't know anything about them. This is the first time you're meeting them. You have to find some similarities between them so they can work together. So what you start doing, you start asking questions to them about, okay, so what's your name, where are you from? And if you're the head of, let's say, a technical project, then you start asking them technical questions. And then from there you understand that from those 6 people, 2 people really like machine learning, 2 people really like web development, and the other 2 people really like app development. So what is this? You have found a similarity between those 2 people. So when you find a similarity between people, what you do is that you group them together. So the 2 people who like machine learning, you're grouping them together. The 2 people who like web development, you're grouping them together. And the 2 people who like app development, you're grouping them together. So in this manner, you yourself, nobody has told you, someone has just dumped 6 people under you, and you're the head of a technical project, and you have to figure out some way that they're similar for you to start working and start bonding together as a team. So what you do is you start asking questions, start finding similarities, and finally, when you find these similarities, you group them separately. So the people who like machine learning, you will give them machine learning projects. The ones who like app development projects, and web development projects to the other team. So now you found a differentiating factor among these people, and you found similarity features. So once you find similar features, you start clustering them together. So one of the very common unsupervised machine learning models are clustering. So that's about supervised and unsupervised machine learning. Yeah. So I think we've already done this many times in the previous sessions as well. So I won't be pausing here for you to go to the Crowdsource app and actually do this. But do check this out in the Crowdsource app. You can look for image label verification as well as semantic similarity. So these are just some tasks that will show you what or how you can say supervised and unsupervised learning in action. All right. Now let's learn a little bit about loss. When we're looking for loss, we're trying to see how different the predicted output of a machine learning model is from the actual output. Now let's take this. These are different models. Now this, what can you see here, that there are some data points, right? And you have fit the best line that you can to these data points. Can you see that there are some data points and you fit a line? You've tried to fit a line. So this action of fitting a line or a best line through the data points you have is known as linear regression. And this is again, since you already know these data points are something that you already know, it is a supervised machine learning model. Okay. Now take a look at these blue dots. So this darker blue dots are the actual data points. Okay. Now take a look at these lighter blue dots. What are these lighter blue dots? Now this darker blue dots are something you've given to the machine for it to train on. Then you're giving it unseen data. So the unseen data, it's predicting it as the probability of an output being here, 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 here. But the actual output lies on this line, right? So you can see that the model predicted that this data point should be here. This data point should be here. This data point should be here, 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 here. But actually the data points should be on the line. That's what that's where the data point should be. But you can see that they're all above or below the line. So you can see these orange lines that indicate how much above or below the line they are. And this orange line is your indication or your measure of what loss is. So can you see this point? Let's say, let's focus on this. Okay, just a sec. Yeah. So let's focus on this point here, just this one. So the actual prediction, what do I mean by actual prediction? I mean that when I gave the model some data, let's say, like I said, I gave the model an image of a dog. I wanted to predict the image as dog, but it's predicting cat. So that's the difference. Now, this is a regression model, which means that we don't get a class as an output, we rather get a number. So let's say I wanted the model to predict 500, but it's predicting 501. So there's a loss of 1 over here. So that is what loss is, how different your actual output is from the predicted output. So if you can see, this is what's represented visually over here. So this is your predicted, this is what has been predicted by the model, and this is where your actual data point lies. So this orange line is your indication of loss, that is how different the predicted point is from the actual point. So they've taken the example of linear regression, which is a supervised machine learning model, to predict this. Now, one instance where you could actually use linear regression is the example I've been saying so far, like where you know how many hours a student studies, and you have to predict how much marks that particular student gets. So you know how many hours a student studies, and you have to predict how much marks he gets. So you can model this as a linear regression, and you'll probably get a final output that looks something like this based on the data that you've been provided. Okay, so you can see that they've used metrics here to measure loss. So now I won't be getting into the metrics to measure loss because there are many. One of the most common one is an accuracy metric, where you basically, what you do is you count the predicted probabilities, the predicted outputs and the actual outputs, and you find the difference between those and represent it as a percentage. So that is the most common way to do that. That is, you find the difference between an actual output that is supposed to be something present on this line and the predicted output that is maybe, if it was a perfect prediction, it could also be present on this line. But if it's an imperfect prediction, then it's probably above or below this line, and it definitely has some loss of some sort. So you can basically try and find out what is the difference between this actual output and the predicted output and represent it as a percentage. So that is one of the most popular methods for you to find, like, evaluation. There's something known as evaluation metric. Evaluation metric basically means you're evaluating your model to see how well it has performed. So if it has lesser loss, that means it's performed better. Whenever there's lesser loss, that is, the loss is minimal in your model, when you're evaluating the model, you understand that it's performed pretty well. So that is about evaluating, and there are a few metrics, like a few ways for you to, identify how much loss you have, and you can evaluate how well the model has performed. So that's about evaluation metrics. Evaluation metric is basically a way for you to evaluate how well your machine learning model has performed. Loss is basically the difference between the actual output and the one that's been predicted by your model. And you can use evaluation metrics like accuracy score to find out how well your machine learning model is doing. So ultimately, what do you want to do? You want to minimize the loss. But it's very, very rare that you get zero loss, because machine learning model is imperfect as well. So if you get zero loss, actually it's an indication that there's something wrong. You can't really always get zero loss. There will definitely be some loss, but what you're trying to do is make it to a value that's near zero. It doesn't have to be zero, somewhere near zero. So yes, so that's about loss. Now let's talk about features. So features are basically things that your machine learning model learns using. Now, okay, so before we get started with features and everything, let's take a look at this problem statement. Predicting the price of a house. What type of machine learning model do you think it is? Is it classification problem or a regression problem?
This is classification problem, basically.
This is a classification problem. Okay. Anyone has any different answers?
It is a regression problem because it's predicting a value for the house.
Correct. Absolutely, Amog. So this is actually a regression problem, because what you're doing in the end, you are predicting a numerical value. So if you were predicting, let's say, a class, that is, I give the machine learning model a few features and I say, hey, is this a dog or a cat? Is this red or blue? You have only two options there, A or B, or you could have more than two options. I'm saying, is this red, blue or purple? What classification is that you have a fixed set of options. You have a fixed set of 2, 3, 4, 5 options. And the machine learning model will predict one of those options only. But in regression, it predicts a number. It does not predict any class. It predicts a number rather. So now moving on to features. Features are something that a machine learning model learns from. So let's look at this problem. We want to predict the price of a house. So what are some features that we need to take into account? The location of the house. So based on the location of a house, definitely the price will either increase or decrease. If it's in a very well set location, the price will definitely be more. Now, like I was going back to this problem, the features for predicting the price of the house could be the location of the house. Definitely, based on different locations, the price could either increase or decrease. The number of bedrooms in the house, the size of the property, definitely. So when you have a larger property, then definitely your price will increase. When you have a smaller size property, your price will decrease. So these are some definitive factors where you can use these factors or these features to predict the price of the house. So features are basically what? Features are some elements that help you find the final output. So let's say I want to differentiate between red and blue. Red has, or let's say I want to differentiate between apple and orange. Apple has certain features, orange has certain features. So apple is red in color, orange is orange. So these are the features that make it different. So when you're predicting the final price of the house, What makes different house prices vary? What makes your house price vary from another person's house price? It could be the location. It could be the number of bedrooms. It could be the size of the property. Now here's the question. Can number of light switches be a feature for this problem?
No, because we are yet to buy it, because number of light switches doesn't come under predicting a price for a house.
Yes, because number of light switches, it does not matter how many light switches you have. That totally does not matter when you're finally having the price of a house. Rather, things that actually matter are the location, the number of bedrooms, and the size of the property. But things like number of light switches, that doesn't matter. Okay, now what about the color of the house? Will that matter?
No, ma'am.
No, color of the house will not matter. If, like, let's say you and your friend have the house in the same location, same number of bedrooms, and same size of property, but yours is blue in color and his is red in color. Definitely the price will be the same only, because color of the house is no differentiating factor in its cost. So these two are redundant features. That is, what is meaning of redundant? Meaning this will not help you predict the price of the house. If you want to predict the price of the house, you need to use useful features like these three. You cannot use these features that do not contribute towards predicting the price of the house. So those are what features are. Features are certain elements that contribute towards getting the final output. Features are some differentiating factors, some things that are unique to that particular problem that help you arrive at the answer. So when you have a dog and a cat, when you have to differentiate, there are certain features of a dog, like, certain features of a dog that make it different from the features of a cat. Similarly, when you have to predict the price of house A and house B, you look at what is different. When you look at what is different, you're attaching a feature towards it. So that is what features are when it comes to machine learning. Okay, now, can one of you tell me for this question, that is, this problem, that is, recommending which video a user should watch next? What are some probable features?
An area of interest before watching any video.
Exactly. Perfect. You nailed that. That was the exact answer. So definitely previous video what they have watched. So now if you watch a lot of gaming videos, what do you get in your YouTube recommends? You get gaming videos in your YouTube recommends, right? So that is definitely one thing. Any other maybe possible thing you can think of? So one is definitely their area of interest. How is their area of interest monitored?
History before they search.
History, that's one great answer, yes. So history will look at how many
history.
Sorry?
Classifying their history into groups like either games or some random YouTube videos or whatever it is.
Wow, that is very good, and that's a real classification problem. That's an amazing answer actually. That is an actual proper classification problem. So you can see that in your past history, if you have 50 gaming videos and 40 cooking videos, it will recommend more gaming videos to you than cooking videos. So that was a very, very brilliant answer. Yes, definitely. Another thing I could think of is perhaps what type of videos you've liked more than the others, right? That could also be a differentiating factor. If you like more gaming videos, then you would be recommended more gaming videos rather compared to the others. Most watched, yeah, okay. So the most watched category, what have you watched the most? Yep, that is perfect. So whatever category that most watched falls under, it will recommend users videos in that area. So yes, look at that. Most of your answers are here. So there's topics, that was the main answer. Then there's popularity of the video, most watched, number of views, things like that. How many times has the person watched this video? And it could also lie within the creator. So you could subscribe to person A more than person B and you watch more videos of person A. So YouTube will automatically recommend more videos of person A. Now this recommendation is not only present in YouTube. Can you tell me where else have you seen this recommended for you section?
Amazon?
Amazon, yep. Can you tell me how Amazon recommends? Like, as in, I'm not asking what goes behind, like what is there in the feature that Amazon recommends? Like
Like if you buy any electrical appliance, like suppose you buy a laptop or Amazon Echo Dot, and it keeps recommending you to buy a say, phone or laptop related stuff like monitor, charger, all those things.
Yes, perfect, exactly. So it says users who bought this also bought this. So that is recommendation. So one is Amazon, then we covered YouTube. Anything else?
Netflix.
Netflix, yes, exactly. So in Netflix, if you watch more horror films, what will you automatically get as your recommendation or recommended for you? Horror films. If you watch more rom-coms, you get rom-coms as your recommendation. So Netflix is a wonderful answer. Any others? You also have Spotify. Spotify also recommends music to you, or Spotify also has a variety of podcasts. So based on the kind of music you listen to and based on the type of podcasts you listen to, it will recommend you those based on your interests. So for a recommendation, these are called recommendation systems. That is, they recommend things based on what you've already seen or what you've already done. So so topic, the popularity of the video, that is the number of views, and the creator of a video. These are very, very good, ways in which you could build a recommendation system. That is, these are very valid features for you to build a recommendation system. But length of a video, is this a valid feature?
No,
No.
Why not?
because if one video is like 5 minutes, and then the other video might be like 15 to 20 minutes of length. It doesn't matter. It might be of the same topic, but in length, it doesn't matter actually.
Yes, okay, that is absolutely correct. Any other answers? So it does not exactly depend. Like if you watch a very lengthy cooking video, but you've only seen one cooking video, but rather you've watched several gaming videos that could be shorter in length, still you'll be recommended more because the main topic of your focus is what? Is gaming videos. So that's why we recommended more of gaming videos than cooking videos, because it depends on the popularity as well as the number of views of that as well. And now age of a video. That is, the video is 2 years old, 3 years old, 4 years old. Is that a factor?
Well, it's not a factor, but example in YouTube, you get the more recent videos than the old ones.
Yes, definitely.
But
They
in
does
actually, that cannot be a recommendation factor.
Yeah, it cannot be. Correct. That's absolutely correct. Yes. So, like Amog and I think Tejas mentioned, usually YouTube recommends the most recent videos to you, and even any other recommendation system recommends recent videos to you. But if you watch a really old video, like let's say you watch a really old gaming video and you're watching like new cooking videos, that doesn't mean that you'll be recommended more cooking videos than gaming videos. It more of depends on what topic that you're very, very interested in. So that's what it depends on here. All right. So that's about certain features. So can anyone maybe summarize on what a feature is? What do you think a feature is? Like so far we've been discussing about, we've taken various problem statements. So previously we had this predicting the price of the house, and you said that these are the features while these are not. Then we have this recommendation system, or recommending which video a user should watch next. Then these are some, you said, features while these are not. So can someone tell me what exactly is this feature?
Feature is not like the feature is a set of properties. Like all these are properties. For example, all these are properties of a video. But the fact that we have to recommend things, so we are only picking up only the main properties from that. The number of views, like number of views, that might be the topic. If you are seeing about cars, it will ask you for what type of cars, like main set of properties for that object or that what you are seeing. So that is
Correct.
it.
Yeah, that's perfect. That's actually a very, very perfect answer. And you're right. So it depends. Basically, feature is a differentiating factor or a property of a particular thing that helps you solve that problem statement. So these are certain properties that help you recommend which video user should watch next. So based on the topic of the user, how many times the user has watched the video and the creator of that video, you can use these as basically features for this recommendation system. So that's about features. Now let's look at this. A baker would like to optimize pricing of the cakes in their bakery depending on previous pricing, cost to make, and time of the year. What about this above scenario makes it suitable for machine learning? Or do you think this is a rule-based problem?
Well, it cannot be rule-based problem because time of the year can be summer, winter, like how people like ice creams, they like it in summer rather than in winter, or in rainy season it may vary. So
You're absolutely right. Exactly. This cannot be a rule-based problem because to optimize the pricing of cakes, it depends on you make different types of cakes in the summer, winter. So a cake that's popular in winter may not be that popular in summer. And to find all those differences, you cannot manually sit and create rules for these. So this is what makes it better for machine learning. And what is the benefit to the business? You can also maybe answer that. If you use machine learning, what is the benefit to this business?
profit.
Yes, more profit.
And there must be automation, like you don't have to think much about the business. It would go tell you whether you are in the loss, whether you are in the profit, and you can also modify.
Correct. Perfect. Tejas, you are absolutely right. And yeah, so like to sum up what you all said, this makes it better. It gives you better results when you use machine learning and it makes it more efficient in this case. So that is the benefit to the business. Now, do you think a human would perform this job better?
In this case, they both will be same because there is a time to be given to that task. So they have a lot of time. It is not.
Any other answers?
Since this can be a machine learning problem, we can automate things like making a cake in a machine, but that rather than sitting and doing each cake every time for selling in a shop. Number of cakes can be done in 1 hour than doing one cake in 1 hour. So that
Great.
is
So that the problem that you're addressing is making a cake. Here, the problem that we're addressing is optimizing the pricing of the cake. So that is, you have, let's say, red velvet cake, and you want to find out what is the best cost of that cake. What is the best price that this cake should have, given how the previous price was, what was the cost it took to make this red velvet cake, and what time of the year it is, whether it's summer, winter. Okay, let's take the example of plum cake. Now, plum cake, right? Based on the previous pricing of the plum cake, based on how much it costs the baker to find all the ingredients to make this plum cake, and based on the time of the year, you basically want to optimize the pricing. So when it is summer, plum cakes usually are eaten in the Christmas time, right? So when it's summer, what happens is the price of this cake will be little lesser. It will be a little more than in winters, because in summer you usually don't make these cakes, while in winters these cakes are very abundant. So since they are more abundant, the sales of these cakes will be more, so the prices will be a little lesser. There will be discount on plum cakes and things like that. But during summer it's quite rare. Like, of course it happens, but the sales of the plum cakes won't be as much as it is in winter. So do you understand these differences, Amok?
yes.
Yeah, so this is where a human can go wrong. A human can just generalize based on, so what I said, this was a human brain working, right? But what if when you put a machine learning model to it, you realize that the plum cakes fare better during a spring season or something like that. So what machine learning can do is basically it uses all the data that's given to it and gives you the best possible answer. And since it's a machine working on it, it's like all of you have mentioned, it's automated, it's more efficient, and you get more accurate results here. So that's why a human would not really perform this job better, and it would be better done with a machine. Now, what are the inputs to this system? Or what are the features, if I may ask?
The sales of previous years means the whole data on which day more cakes were being sold and which weather it was and how the conditions were.
Correct, correct. Any other features?
And the like the you have put a cost to make it like now how much that the batter cost you or the cream cost, and you're putting each and every ingredient there, the each cost, and with along with the time of the year. If the cost of the batter is too less in winter, it might be more in summer or spring. So you're putting all types of inputs so that it could make a pricing for the cake. And
Perfect. Yeah, continue. Sorry.
like if it is in summer, the pricing of the batter is more and the pricing of the cream is less, so it will take two more or three more in data points what we have inputted to the system, and it like kind of make it an average and do the pricing for the cake at the time of the year.
Yes, that's absolutely correct. And that's a very perfect answer. So, whatever Tejas and Amol, both of you, whatever you said, that is exactly what are the features for this. That is what are the features for this particular machine learning model. Now, whenever you're building any model, you must always think of ways in which it can go wrong. So, what do you think are the ways here that the machine learning model can go wrong?
The cost of the raw ingredients could get high because of some crisis or something like that. So it may go wrong.
May go wrong. So, what you're trying to say is that maybe the data given to it is not perfectly correct. So, the prediction could go wrong there.
Yes, because something like if we just take off oil, if the crude oil is not there or the workers are on the strike, so indirectly the price of oil increases and that cannot be understood by a machine.
Yes, that is perfect. So, unseen scenarios, like scenarios that we've not even trained the model on. So, for those scenarios, it could give you a wrong output. So, yep, that is perfect. Perfect. Very perfect answer. So, again, I think we just have a few more points that are like this. Maybe in interest of time, we'll go over one more because we're already a little past time. So here, if someone could sum up this, an ocean conservationist would like to track fish population over time. So do you think this is a machine learning model? And what do you think would make it suitable for machine learning?
I would say it is machine learning model because ocean conservationists cannot go to each and every ocean and count each and every fish in the ocean. So it would just track one of the type of fish, then number of population. I mean like number of populations in this place and the other place, so that he could get the average number of fish. You know, number of fishes in that place.
Correct, exactly. So it basically predicts the population of fish based on all the previous data that it had. So maybe today you have 200 fish, and like maybe last year you had like 400. So before that you had, let's say, 600. So based on all this data, you want to predict maybe next year what would be the population of fish. So like Amog mentioned, you cannot really go to every ocean, count the fish. You can't really, sit and calculate on your own based on the previous data. So rather, it would be better if we can model this using machine learning. So again, benefit to the organization would be the same as before. And do you think same as before, as in it would be easier and the answers would be more accurate and it would be more efficient? Now, do you think a human can perform this job better?
No human
Not
can
possible. No.
perform this job better as there are a large number of means counts is until in lakhs and crores, so which cannot be handled by a human as perfect as the machine could handle it.
Correct. Exactly. Perfect answer. Yes, and that's right. So a human can't really on their own manage so much data. So that's why we require a machine to help us understand the pattern that was there in the data and model it in that manner. So what do you think could be the input to the system?
The places
The
where the
population growth
fishes.
rate of the fishes and their numbers increasing by the month or the year as per the organization's need.
Correct. And Amog, you were saying something?
The places where like this particular fish is found and this population is more, so that we can track the number of populations more accurate.
Perfect. Very. That's pretty insightful. Both of you gave really good answers. So Tejas, you mentioned the growth rate over time and things like that, and Amog, you mentioned based on a place, and that's all. Both of these are very very valid features and things that could actually help you predict what could be the fish population over time.
Another
Now,
one thing,
yeah,
the season of the year.
season.
Season,
Yes.
yeah, it can be easily we can predict. Some seasons, some fish is not available in some area. In another time, we can it will available over
Correct.
the
Yeah.
time.
That makes a lot of sense. So it depends on the season as well. And another thing it could also depend on is, let's say, water. So if the water is more polluted and things like that, then the fish population would be decimated. And there are certain fishes that are freshwater fishes and saltwater fishes. So this could also perhaps be one of the features that helps you track the population of fish. So all three of you gave really very very valid features that could be used for this problem. Any others? Okay. So how do you think this model could go wrong?
There can be like the sharks may be more as their population grows. So the population of the fishes may go down and that cannot be tracked by a machine.
Correct. Correct. Very good. So these are again, like previously, there was some unforeseen circumstances about the ingredients. Here, the unforeseen circumstances can be about the actual fish population. So you may not know if it is exact. If it could be, inaccurate data because of current things that are taking place in motion. So
And the
that's
fishes may not be in the same place. It will be migrating from one place to another. So the number of places where it is found may vary, and the places may vary. So it can go down, it can go up, anything can happen. So this machine learning can go wrong there.
yep. Definitely, that is perfect. So you can't
In fact,
perfectly.
it would be mostly wrong as per my opinion.
It could, so maybe you can maybe someone has made some advanced tracking system that maybe helps you track one particular type of fish, helps you track its behaviors and things like that. Still you will not have perfectly accurate data, but you're right, it could go wrong in many places here because of there are so many inconsistencies, so many variables that could happen. Like you mentioned, the fish could migrate from one place to another, a shark could eat it. So because of all of this, you don't exactly know the value of the fish population at that particular time. So yeah, again, these I will be sharing the slides so you can look through these other two. Like you can think of your own scenario. I think this is not meant for this session. You must rather go back home, reflect on the 4 sessions that have happened so far, and think. Like I always say, look at real world examples around you. Maybe look at places where you actually think people are suffering in, and check if machine learning can be used in that area. If it can, then always think of these 5 points. What is the scenario that's making machine learning, that makes it suitable for machine learning? This first question is very, very important because sometimes machine learning is not really required. So in those cases, you can reject the rest of it at all, because if machine learning is not required, you don't need to go further. Then you can understand, based on if machine learning you see is required for that particular problem, then you can understand, okay, based on this, how can I benefit the individual? Then you think about it and say, hey, can I manually do this job better? No, I can't. Okay, I cannot. Then you go on to the next steps and think of what inputs can you give to this machine. Now you have thought of a real world example. You've understood that machine learning is what makes it beneficial for this business, and you do understand that humans can't perform it well. Then you start thinking of the features. The features are basically the data you feed to the model. Again, that is what the input to the model is. So previously it was fish, before that it was the previous price of the cakes, the time of the season, and cost of ingredients and things like that. So based on that, whatever you're making, whatever model you're making, think of what the inputs to the system are, and always think of what could go wrong. Where could it go wrong? So when you think of what could go wrong, You'll think in that direction, so you'll understand where to fix your model. So these are some things that you must think of when you're trying to create your own machine learning model.